Okay, perfect. So, first, just a quick summary of the situation. We don't have any lecture on Thursday. And do you remember that? I already mentioned it to you because it's degree day. So we are meeting today and we will meet again on Monday next week. Next week on Monday, don't bring your PC, maybe on Thursday, but I tell you on Monday, okay? That's perfect. So before we start, I just want to give you a few details about the computation of the flow duration curve, because when we start working on the PC, I want to make reference to this specific exercise. I will give you some observation of river flows for maybe the Po River, not sure. And then I'll ask you to compute together with me, we will work together, the flow duration curve for the case that I will give you. Before doing that, I need to explain to you in practice how the flow duration curve is computed. I introduced to you what is the flow duration curve. Basically, I'm not sure I gave you the definition. In any case, I remind it. So the flow duration curve, it's a tool for assessing, we know that, water resources availability. And the definition is that the flow duration curve for a given river cross section, so for a given river cross section, we make reference to a river cross section again, we defined it, reports for each river flow the percentage of time or the duration in absolute term with respect to a reference period that the given flow is equaled or exceeded. And I repeat it, the wording may be different with respect to what is written on my webpage. Just concentrate on the concept. So with reference to a river cross section, the flow duration curve gives for any river flow the percentage of time or the time duration with respect to an observation period that the river flow is equaled or exceeded. Okay? So for instance here, you see a given river flow here, and you go on the curve, and then you go down on the abscissa, and you get the duration. The duration again can be expressed in percentage term or in absolute term. What does this mean? You refer to a reference period. Let's suppose it's 1 year, but it may be 10 years. So if you refer to 1 year, the duration is again the percentage of time of the year that the given river flow was equal or exceeded. Okay? If you refer to absolute terms, the duration is expressed in days, for instance, like the river flow was equal or exceeded for 3 months, 90 days. Okay? That's it. In order to compute it, you need observations. You need the hydrograph, which is reported here. And therefore, you need numbers. Numbers that tells you the river flow for the given observation period, and the river flow is observed at a given time step. We already discussed about it. Let's suppose that we observe the river flow every day. So the time step is daily. Keep in mind, when you have a time series of hydrological variables, maybe river flow, maybe rainfall, keep in mind time series means a sequence of observations in time. We already recalled it. And you have to think soon at the time step. So what is the time step? This is the first question. Observational time step. It may be days, it may be months, it may be weeks, it may be minutes. Today we have some rainfall observations at a time step of 1 minute. Okay? So typically for the flow duration curve, observations are daily, and I say typically because if you look at the national archives in several countries, at the beginning they observed the river flow every day. They didn't have the means, the tools to observe at a finer time step. Okay, so we will have a time series of daily observations, and we have to compute the flow duration curve. How to do it? It's very, very simple. So let's suppose that, let's skip this. I think here, yeah. Let's suppose that we have 1 year of observations, and it's a bit, you can't read here, I'm sorry for that, but I tell you. So let's suppose that we have 365 observations daily for 1 year, okay? The reasoning is the same if you have 10 years. In this case, you will have 3,650 observations. So let's suppose that we have one here. What we have to do is to collect all the observations in a file, in one sample. One sample means one example. In our case, it's a file with numbers. And we have to rank them in, let's agree that it's not ascending but descending order. It doesn't matter, but let me refer to descending because it's easier, okay? So we have to rank them. And let's suppose that we rank them from the highest to the lowest, descending order, okay? And then we identify the position of a given observation in the ordered sample. Let's say that I have the river flow which I want to refer to is the 10th, okay? Perfect. This position is precisely the duration. Okay, because let's suppose that you have, again, the sample, it's ranked in descending order. And then this is the highest. This is the lowest. Okay? Now, it's clear that if we get this one observation, which is at the 10th position, what does this mean? That for 10 days, this river flow was equaled or exceeded. This is precisely the duration. So, estimation of the flow duration curve is very simple. You put the data in descending order, and that's it. And of course, the 10th position, duration of 10 days, this is expressed in absolute terms. If you want to express it in relative terms, of course, the duration will be, let's suppose that I call the position I have to divide by the duration of the sample. For reasons that I'll explain you later, let's suppose that the duration of the sample is n, in 1 year is 365. For reasons that I explain you later, we don't divide by n, but we divide by n plus 1. So this is in relative terms, relative duration. Again, I'll explain you later why plus 1 and not n. Just keep in mind that for an engineer it's the same thing. If you divide by n, if you divide by n plus 1 is more or less the same, okay? But I'll explain you later why we decide to divide by n plus 1. Okay, that's it. This is our exercise. Very simple. Questions? Good. Okay. Now, we can turn to our exercise. First of all, let me disclose the exercise on my website because it's not yet disclosed. I'll do it right now. It's here. So, I go back to the web page of the course and I'll display the exercise just below short introduction to R&R Studio. You see it here? This is the short introduction. I display the exercise up there. Or no? So, let me just do it very quickly. Edit. No, sorry. Okay, now you are able to see it in the English version. I will do it soon on the Italian version. And just download the PDF and let's read it. Okay, now you see that there is a download link, exercise, estimation of the flow duration curve. Let's suggest on the first link. On the right you see suggested R file. Let's forget it for now. So if I click on the exercise, I get in download a zip, and we can read the PDF. So this is the file that you should have downloaded. Okay. Everyone does it? Have it? Yeah, no problem. Better. Okay, so let's read it. It's computation of the flow duration curve for the Po River and Ponte Lago Scuro. Ponte Lago Scuro is close to Ferrara. It's, as I said, it's conventionally adopted as the closure section, the closure river cross section of the Po River. And just to give you an idea, the extension of the catchment for the Po River and Ponte Lago Scuro is about 70,000 square kilometers. 70,000 square kilometers. It's quite an extended catchment. Is the largest catchment in Italy. Okay, we have a time series there that is quite long because being an important river, we have daily observations since about 100 years ago. So, the river cross-section of the Po River and Ponte Lago Scuro, I'm reading, mean daily river flows were observed since January 1st, 1920, up to December 31st, 2009. We are still continuing the observations. Be patient, I didn't update the time series in the past 5 years because we don't get the data soon. And we could update it, but okay, let's forget about it for now. Data are expressed in cubic meters per second and are reported in a text file which is included in the zip that you downloaded. Okay, and the data observed on February 29th of leap years have been already removed. So we removed all the observations collected on February 29th. And so the student is kindly requested to, let's forget only the first question, estimate the average flow duration curve by pulling all the observations together, therefore obtaining a high resolution representation. Okay? Okay, just a few comments. First of all, the units, cubic meters per second, I told you it's the usual unit that is adopted for river flow when the river is large. If the river is very small, it may happen that you see liters per second. In this case, keep in mind, I already mentioned to you, 1 cubic meter is 1,000 liters. Okay, now, the text file. What is a text file? So, some of you may already know what is a text file. A text file, the text format for files, it's a format that is considered to be universal. It's readable by several platforms, several software platforms, is easily readable by Notepad in Windows. So if you double click and you are a Windows user on it, Windows should open the text file with Notepad. It can be easily read by Excel, it can be easily read by MATLAB, R, whatever platform. So this is why we adopt usually when we want to exchange data, we may adopt this format. The inconvenience is that it takes quite a lot of space in the file, but it can be compressed. In our case, it doesn't take much space, but when we handle millions of data, the text file is a bit, it takes a lot of space. But the big advantage is that you can read it in both Excel, R, whatever, okay? Fine, and the big question is how to read in R the text file. This is one of the first big questions that we have to discuss together. Okay, and then here, average flow duration curve. What does average means? we have an observation period that is 90 years, 90 years. And average means that the duration is expressed with the reference period of 1 year. And of course, if we adopt 1 year as a reference period, we may compute here 90 different flow duration curves, one per each year. And we want to compute the average. And this is fine. I mean, if you have a long observation period and you still refer to a period of 1 year to compute the flow duration curve, your estimation becomes more robust, because if you take the average, it's representative of what happened in the 90 years on average, which is fine. Okay, now let's place your text file. You should extract it from the zip file and put it in a convenient folder. My suggestion, if you are a Windows user, is to put it under Documenti or Documents. Okay, let me just be clear on that. The text file is included in a zip. The zip is a compressed file. I assume that all of you know what is a zip, what is a compressed file. If not, if you have any doubt, raise your hand, please. No problem, because you know, we come from different backgrounds, different countries, so maybe that you don't know what is a zip or compressed file. Please raise your hand. Don't be shy, okay? Now, the zip file, the compressed file, can be, we say, exploded, meaning that you uncompress it, and you have to decide where to place the uncompressed files. You may place them wherever you want, but my suggestion is, for now, to place it in Documents under your username. If you open a file manager, in Windows is called Gestione Risorse, which means resources management in English, I'm not sure. But if you open a file manager, you can take the zip file and put it in the folder Documenti. Is this clear for everybody or not? So if you have any doubt, please. Everybody saved it in Documenti? Okay, don't worry, again. You don't make your reputation at risk if you tell me that you cannot manage files, absolutely, okay? You put your reputation at risk if you don't tell me. If I realize later that you could have raised your hand and you didn't, I wonder, why is that? I mean, so don't be shy, okay? Good. Now, given that you have the text file in Documenti, uncompressed, now let's start R. Okay? So double click on R. In my case, the situation is different. So what you see here, and let me enlarge the fonts, it's not what you get on Windows. It's very similar, by the way. So let me just enlarge the fonts. In my case, I just have to write R, and then I get this. It's too large, the font, just 1 second. Just 1 second that I start it again. So you should get some writing like this. It's in Italian in my case. I'm sorry for that. I tried to install it in English and I was not successful. I don't know why. So basically you see that R is a project of collaboration with many external contributors, etc. And you see a list of sentences. At the end of the story, you get, let me see, because still it's too large. try to go back to. Okay, much better. At the end of the story, you get a major sign there. Okay, if you want to clean the screen, first of all, you don't see only this window. Under Windows, you see a bigger window, and on the left part, you see a smaller window with these writings. If you want, you can expand the smaller window to occupy the whole window. And you just click on the right icon. It's not necessary, it's just a suggestion, and you get something similar to what is shown here. I don't have the menus, you have the menus. Let's forget about them for now, because the menus are just shortcuts for instructions that can be given by writing here after the major sign. Okay? Let's clear the window by pressing Ctrl plus L. You see that I cleaned my window. And then you see the major sign with the black square. I'm still struggling to find the optimal font size. I think 22 is what I know, 16 is what I'm looking for. Okay. Now, what does this mean? The major sign means I'm waiting for your input. Ready to get your input. This is what the major sign in R means. And the black square identifies the cursor, meaning identifies that the system tells you that the system is waiting for your input from keyboard. So this makes a big difference with respect to Windows that generally uses menus. It doesn't use input from keyboard. Windows uses input from menus from Windows. So you are used to use the mouse under Windows, click on the menus and find the commands that you wish. In this case, the system wants the commands through the keyboard, and therefore the difficulty is that you have to know what commands are available. In Windows, menus are useful because you see a list of the commands. So in Windows, when you want to save a file, you just look under the menus for the command save and maybe the icon. Here, you have to know the command that tells the system that you want to save. And you may say, but why is that? Why don't we use Windows then? Why don't we use menus? The reason is that when you use menus, you have available only a limited list of commands. You can't put 1,000 commands in a menu, because otherwise you don't find it anymore. So Windows made the choice of putting you available only a limited list of commands so that you can see them in the menus. Platforms that are more flexible, they decided to use the keyboard because in this way they can give you millions of commands. Of course, you have to know them. So this is a platform that is called less user-friendly but more flexible. What we can do in this platform is to make computations like we do in Excel. So the counterpart of R in the Microsoft setting is Excel. The difference is that R is much more flexible, it's less user-friendly. So why it's useful to learn R? Just for the reason that if you want flexibility in your computation, you have to learn how to use a flexible software. For day-to-day daily business, okay, usually I don't suggest that you use R. If you have to compute a sum of 1,000 numbers, it's better to use Excel because it's easier, it's quicker. Okay, but if you need to make more complicated tasks, it's better to use R. For instance, let me give you a very simple example to clarify what I mean. Suppose that you want to depict a graph of whatever, like river flow, depending on time. And you want to put the labels on the abscissa where you want. So you want to put a label at time 0, a label at time 7, and a label at time 10. Label means that you put this small mark here and the number below that gives you the value of the abscissa at the small mark. This very simple operation can't be done in Excel. Excel doesn't allow you to use labels that are not equally spaced. Okay, R allows you to do that. So this is a very simple example. Of course, you may say, I don't care about putting labels where I want, but yes, but you may care in your professional career of other tasks that you can't do with Excel. Another very simple example is, let's suppose that you have to handle 1 million numbers. Sometimes you have hourly observations of river flow for 100 years, and then you get maybe not 1 million, but you get a huge number of data. Excel, when it has to deal with a lot of data, becomes very slow. R is much quicker. Now, keep in mind that in your career, you will have to take care of being very rigorous, of being very careful, but also of being quick. So we have in Italian a proverb which says that you can't do one thing quickly and rigorously. We say that you can't. Actually, I think you can. So it's possible that you make something very rigorously in a quick setting, with a quick solution. But of course, you have to take care of maximizing your efficiency, because and to do that, because of course you have to know different solutions. To do that, you need to know alternative solutions. So this is why I like to teach you several approaches for solving a problem, because once that you know, you can select the quicker solution, the most efficient. And you know, sometimes the task of the engineer requires computing many computations in the same day. Like the same kind of computation is to be repeated like 1,000 times, which is easy with the PC. But you understand that if you use Excel and each computation takes you 3 seconds more, at the end of the day you work at 1 more hour, which is, you may say, okay, I don't care about it, but indeed it's something that makes you less competitive with respect to another engineer that makes the same computation in 1 hour less. And I tell you, this is something that's really important, because today everybody is hurried. So you get clients that come and say, in 30 days I need the results. And if you give the results after 35 days, they next time select another engineer that is timely. So this is extremely important: timeliness, efficiency, rigorousness. And this is why you need to learn to use the computer very well, because you know, the task of the engineer today, the profession of the engineer today is on the PC. And so, okay, now, so let's learn these commands: how to make a graph, how to perform computations. First of all, keep in mind that you can use R as a calculator to play with numbers. So if you just type 2 plus 2 and then you type return, it gives to you the result. Very easy. And you can make whatever computation in whatever sequence. And therefore learn what are the priorities, like 4 plus 2 times 3. The result is 10 because the multiplication is computed first. Priorities are important. If you want to establish a different priority, you have to use parentheses. 4 plus 2 times 3. You can use an unlimited number of parentheses, whatever, and you can also use the power 2 to the power of 3 with a hat. Okay, this is very simple as well. And another nice thing, let me clear the screen. Another nice thing, you can memorize variable. A equal to, and then if you write A, it's 2. And B equal 3, and then you can compute A times B. So you can put variables in memory, and if you want to know what are the variables that you memorized, you need a command, which is the list command abbreviated in ls. But don't press return, because if you press return here, you get something that is ununderstandable. ls is a command, it's a function, and it's called a function in R. Functions must be given arguments between round parentheses. So you have to open a round parenthesis, and you have to know what are the arguments to be given. If you don't give any argument, R takes defaults. And you see that here it lists 3 variables that I memorized. C is from a previous run of R. In making this example, I already introduced to you the concept of function. R has several functions. And I told you that you need to know the arguments. So your question may be, how can I know what are the arguments of a function? Okay, so this question implies actually 2 questions. First, how can I know what is the name of the function in R that performs the tasks that I want to perform? So, this is the first question. The second question is, once I know the name of the function, what are the arguments? Okay, so let's suppose, for instance, that I want to compute a summation, or let's focus again on the list function. Let's suppose that I don't know the name. How to get the name? What I suggest is open a browser, go on Google, and then search for R project list of variables. And then you press OK and go quickly on the first link. OK. Look here. Getting information on a data set, list objects in the working environment, ls. Good. This is what we want to search. Okay? Perfect. Now, if you go down, maybe that you find also the list of the argument, but no, it's not here. But let's forget about it. Let's make another example. Let me go back in Google. R project. Logarithm base 10, oh sorry, base 10. I go on the first link. Look here, log 10. Usage, log. Look, in this case, the help gives you both the name of the function and the arguments. So let's look here. Log x. X is the number I want to compute the logarithm of. And then there is a second argument. You see the comma. Base equal exponential 1. What is exponential 1? Is e. So I understand that there is a command, an argument that gives to the function the base. But given that there is a value that is proposed, it means that for that argument you have a default. Having a default means that you can avoid to use the argument. If you don't have a default, you have to give the argument. Is this clear? So let me make an example. Let's refer to the logarithm. So I go back to R, and let's refer to the logarithm. Okay, so let's suppose that I make log, and I don't give any argument. You see? Error. The argument x is not specified and doesn't have a default value. It means that for x I don't have a default, and indeed here you see that x is listed alone without a equal to something. Okay, good. Now I can write log 10 and it's computed. But let's try to use the second argument, log 10 base equal 10. 1. Good. In this case, I gave also the second argument, which is the base, and I cancelled the default and I adopted 10 as base. I overwrote the default. Okay? Same thing if I did log 10 of 10. Log 10 is a function logarithm in base 10. I go back here. You see that for log 10 and log 2, you don't have the opportunity to specify the base. Log 1p, I don't know what's that. Let's forget about it. I just want to show you that if you look on Google, on the web, you easily find the name of whatever function you need, provided it is embedded in R. But if you stick on very usual functions, they are there. And when you look in Google, don't write just R project, because otherwise, you know, Google may get confused. Again, if something is not clear, please raise your hand. Now there is the list of the argument. In the case of the logarithm, we found everything on the web. But once that you know the name of the function, you just may press the question mark and then followed by log without space.